Hi everyone, welcome. For the past 10 years, Alembics have been powering production pipelines around the world. It is the industry standard format supported by dozens of mainstream 3D softwares. In the next few minutes, I'm going to be demystifying some of its technical aspects, enabling you to easily exchange your work between various 3D softwares. Most of the CG artists are challenged when it comes to transferring 3D models and animation from one software to the other, especially for shading and rendering. By the end of this video, you will be able to harness the power of Alembics in your personal or professional CG work. In fact, Alembics enable you to build your own DIY CG pipeline at home, round-tripping data between softwares of your choice. For that, we will start with basics and learn what are object hierarchies and how softwares such as Maya, Blender, C4D, Houdini, and Clarisse represent them. We will learn the difference between transforming and deforming animation, go over Alembics' strengths and limitations. As a bonus, we will fire up SideFX Houdini, set up a simple scene, animate and export a transforming cache for shading and rendering in Blender, C4D, and Maya Arnold. My name is Gaurav Mathur. I'm a VFX professional working in the advertising and motion picture industry. This is my humble attempt at making instructional video for the larger community. So let's begin with basics. In the most common DCCs, 3D models are represented as objects. Object hierarchies or ranking order is parent-child relationship between different objects. Let's take a simple teapot made up of two separate models, namely lid and body. Without the lid and body, there won't be any geometry left. Therefore, we can think of the teapot as a placeholder object, which is often called null, locator, group, xform, empty object, depending on your 3D software. Typically, in a given 3D software, once a parent-child order is enabled, a child object will directly inherit transforms such as translation, rotate, and scale from its parent. For example, if we define teapot object to be parent of its sub-objects, then upon moving, rotating, or scaling the teapot object, its children, lid and body will come along. Very straightforward. Let's see this in action. So here we are in Maya and its classic outliner. We can select and move the lid and body independently, and upon selecting teapot group, everything follows together. This is Houdini. In its network view, selecting and moving the null node moves the entire teapot. Lid and body objects are free to be moved independently. This is Blender's outliner. Lid and body can be moved on its own, and when moving empty object, both lid and body come along. C4D is no different in representing rank order. Body and lid can be moved independently and both change position upon moving the teapot null object. Clarisse has got amazing support for Alembics. In its hierarchy view, we can select the teapot xform object and translate the entire teapot. However, lid and body can be moved independently. So that's pretty easy. Before moving on, let's understand what we mean by transforming and deforming animation. Changing object scale, rotation, or translation controls at group, empty object, locator, null, or xform level is commonly known as transformation. Individual operations can be combined to generate intrinsic motion. On the other hand, we have deformation, which is relatively straightforward. Think of resulting character animation from underlying blend shapes, rigging, and skinning. It's about changing mesh's vertex position in local space. With jargon out of our way, let's get to Alembic. Alembic is an open source geometry caching format developed by Sony Pictures Imageworks and Industry Light and Magic. Since its release in 2011, Alembic has been widely adopted across the industry by big studios to very small teams working on visual effects, animation, and motion graphic content. Alembic has found direct support in dozens of DCCs. On disk, files are often known as archives with .abc as extension. Alembics are efficient at storing the final result of any geometric modifiers. That means we can use them for exchanging 3D models with or without hierarchies between softwares. We can exchange animated transform and deforming caches. It also supports exchanging additional data types on 3D models, often called user data, properties, or attribute such as UVs, vertex color, which is very useful for shading and rendering. Apart from polygon meshes, there are other supported primitive types such as subdivision surface mesh, open polygon curves, points or particles, NURBS patches, etc. However, covering each one is beyond the scope of this video. With all that variety, there are few limitations. It does not support storing any representation of rigs required to produce the final animation. It also does not support textures, shaders, or material definition. Well, that brings us to the end of part 1. In the part 2, we will continue with demo of Houdini's powerful surface operators known as SOPs. We will see how Houdini's native packed primitive workflow can be used for preparing object hierarchies and exporting transforming animation caches, which we will later modify, shade and render in Blender, C4D and Maya R-Node. Hope you learned something new and enjoyed as much as I am making it. Do provide any feedback in the comment section. Your valued suggestions will help me tailor future video content. Thanks for watching. Until next time.